Here we go. The first question, in some of these I didn't write down the directions, so it's in my lunch bag. Here's the first one, and they want you to rewrite it. Now, I'm just going to rewrite it. You're going to use the identities. Sine of 19 pi over 12. And they want you to rewrite it using the difference identities. Sum and difference. In this case, it'll be difference because it's a what? It's going to be a subtraction. Sum and difference identities. Now, what's the first rule? Find what? Where you are. That's the first thing I would do. In my hand so I don't not look at them. So what is 19 pi over 12? (285 degrees). So let's draw that out because we need to know where we are. 285 degrees is above what? 280, right? Or 270, right? So you've got to figure out two angles that will give you 285 degrees. So what two angles will give you 285 degrees? Well, you know you got to find one in the, what's your special angle in here? 330? Okay, subtract 285 from 330. What do you get? That's another special angle. Minus 45. So now you just got to turn 330 and 45 into pi over whatever. So sine of 19 pi over 12 is equal to the sine of, and I got it written down, 11 pi over 6. Which is your 330 degrees, minus pi over 4, which is 45 degrees. Now, use your difference identities. Sine, cosine, minus cosine, sine. Sine, cosine, minus cosine, sine. Plug in what? Plug and chug. Is this a test question? Yes. I don't think I would use 19 pi over 12 though, but what do you do when you see 19 pi over 12? What's the first thing you do? Talk yourself into what? Quitting. But that's why the first rule is to find where you are, because that lessens the what? The anxiety. You can still quit, but at least you can quit knowing where you were. It's a better feeling. It's kind of like being in a dry box instead of a wet box, you know, in the ditch. Either one. So, 11 pi, oh, and now Tulsi Gabbard is a Russian spy. And so is, what was the woman that ran the Green Party last year? What's her name? Jill Stein. She's a Russian spy too. You know who's doing all this? Hillary. I think she's lost her damn mind. Everybody is a Russian spy. They're in her own party. I think she's crazy. 11 pi over 6. Pi over 4. Look at this. Just 11. Will y'all quit whispering, please? That irritates me. Pi 45. Yeah, y'all. Quit whispering. All right, now go to your special angles and write it out.
I think you've lost your mind.
I haven't lost my mind. Why do you think I've lost my mind?
You think we're weird stuff. Right. We don't talk, remember?
Yeah, y'all whisper, which is even more impolite.
Had to come off of the x-axis.
Wait a minute, somebody's actually talking math. I heard x-axis. Wow.
I was wondering.
Somebody's going to beat the crap out of you if you're talking Pendleton.
This is Oconee.
What? Oconee, what was the question?
Oconee. 330. I don't understand when you got the 330. I thought you come off the x-axis.
Yeah.
Why not subtract 360?
You could. You could, but you'd have to come out, make sure you come out with 285. You don't have to do it one way. I just picked 330 and 45. Is there another combination?
I'm not sure.
360 minus, or 360, I don't know if you can get 285. You'd have to play around with it. I'm not thinking right now, so I don't know if you can do it or not.
Okay, you just pick something to come off to get.
As long as you can get 285, because this right here is 285 degrees.
Right.
So if you can get 285 degrees with a sum or a difference, then knock yourself out. Negative 1/2, y'all check me. This is what I came up with. Negative 1/2, square root of 2 over 2, minus square root of 3 over 2, square root of 2 over 2. And that's going to whittle down square root of 2 minus square root of 6. That's 3 dots. Over 4, which will give us, that's basically the answer.
What happened in the negative before the 1/2? Wouldn't that be negative 2 minus, or negative square root of 2 minus square root of 6?
Yeah, I got it right there. I'm sorry.
Okay.
I've dropped it off. Thank you. Negative's right there. Okay, on 3, everybody say it. I was thinking that. 1, 2, 3. Okay, all right, thank you. Now get it out. Why do y'all do that? Y'all wait until I finish the problem. You wait until usually a female says, well, that's supposed to be negative. And then when I say, yes, I dropped it off, everybody goes, yeah, I thought that's what it was supposed to be.
You're just so scary.
God, that irritates me. I've lost my mind, is what it is.
Guess you got a drink.
What'd you say, Pendleton?
Huh?
You're not going to say anything. Here is a formula that they give you, and basically you got to plug and chug. They give you 0.6 W. Of course, if you're from around here, you say W. Sine, that's times the sine of theta plus 90 degrees over sine of 12 degrees. Okay, they give you this formula, and the first thing, A, says calculate F when W is equal to 165 pounds at theta is equal to 45 degrees. It's some kind of formula when you bend over and pick up or straighten up how much force is on your back. Okay? So if you weigh 165 pounds and you turn 45 degrees, how much force is on your back. Okay? So plug and chug. F is equal to 0.6 times W, limbs on, okay, times the sine of 45 plus 90 over the sine of 12 degrees. All right, go to it. Now they want, yeah, go ahead and do it, because all it's going to do is be, I calculated 0.6 and 165 as 99.
Yep.
So that's going to be force is equal to 99 times sine of 135, of course, over the sine of 12. And when I crank that out, that comes out to be about 337 pounds. So that's A. This is not particularly a test question. might ask this as a test question for bonus points or something. But I know most of y'all can use a calculator and plug and chug. This section is on identities. So B, you actually use an identity. So we'll go ahead and go to B. Let's see if I can do this, because I haven't had training. Nope, that's not going to work. Won't have to erase it. B says, use identity to show F is approximately equal to, use identity to show that F is equal to 2.9 W cosine of theta. In other words, they want you to reduce this side right here. They want you to use identity, ding, 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 sum and difference identity. Use an identity to make this look like this. So I just gave you a hint. Sum and difference identities. Sine, cosine minus cosine, sine. I'll write it over here. Sine, cosine minus cosine, sine. Plug and chug. And I just work with the parentheses, the theta plus 90. We did one of these in 9.2 or 10.1 or 10.2. Remember when we took the sine and got 0 and one of them canceled out? That's what you're going to be doing here.
Would that be plus sine, cosine plus cosine, sine?
Sine of A plus B is equal to sine cosine minus cosine sine. I'm sorry, it would be plus, thank you. Okay, everybody on 3. 1, 2, 3.
Yeah.
Okay, thank you.
Because I had.
Yeah, man, you wrong. Bubba's sitting on the back row, don't even know what day it is. Thank you, Miss Minnesota.
We're
You
not
just think you're
scared.
better than I am, don't you?
No, we're not scared of Minnesota.
Okay. Yeah, you got a mayor in Minneapolis. He's a dang it. Sorry.
I don't live there, so I'm
I
not
know. Didn't you grow up there?
No, I mean half my childhood was
Okay.
in the area.
I'm from West LA. West Lower Anderson.
So have the Fresh Prince song stuck in my head.
In West Philadelphia.
Born and raised.
LA.
I loved him until he opened his mouth about politics, and then I told him he was stupid. So.
Has he talked about politics?
Oh yeah, he's one of those DiCaprio people. He's out there floating. Yeah, DiCaprio has got his own jet, but he worries about climate change. Do as I say, not as I do. Al Gore in his private jet. Okay, so that's going to be 0.6W times the sine. I'm just going to put this in brackets. Sine, cosine, plus cosine, sine. And some of y'all, I know what you're doing. You're looking at this stuff and you're going, I have no idea where to start. Okay, when you see this problem and you say, okay, I've got to rewrite the identities, where should you focus? The first place you should focus is right here. Because why? There's nowhere else you can use an identity. That's the first thing you should focus on. You can't focus on 6W. You can't focus on sine of 12 because you put sine of 12 in your calculator. Believe you me, I remember how identities can be. Just look at it, stare at it for 15 minutes. But none of y'all do that because y'all know it, right? Nobody's going to say anything. So here we go. Sine of theta, cosine of 90, cosine of theta, sine of what? 90. We're going to take our handy dandy unit circle. And this is what? 1, 0. This is what? 0, 1. It's -1, 0. And this is 0, -1. And we're focusing on this guy. So this is our cosine, and this is our what? Now you just plug and chug. So 0.6W sine of theta, we don't know what theta is, so we just rewrite it. Cosine of 90 is what? 0. I'll do that in the calculator in just a minute. Plus cosine of theta is 1. I'm sorry, I got it bass accurate, sorry. Cosine of theta times 1 over the sine of 12 degrees. And what happens? Punch it in your calculator. Sine times 0 is 0. So that goes out. And you're left with cosine. And somebody divide, well, you don't have to. Well, take 0.6 and divide by the sine of 12. 2.885 W times the cosine of theta, and you should feel good about yourself. And when you're looking at these, hopefully you start to see what you're doing. You're taking one method to rewrite another method. Nobody is ever going to go up to you and ask you this stuff. But how do you train the problem-solving process of your mind? You can't do it with history and Western Civ. You can't do it. If you're going to train the problem-solving process of your mind, you have to have math and science. How many of you would like to cross a bridge that a sociology person designed? Now, the last part asks you to graph it, and I'm just going to show you what the graph looks like because it's going to be the same graph on each question. So I'm just going to erase this, and I'm going to show you what the graph looks like, and that's going to be on all these questions probably. The graph is going to look like, and it's a sine graph, or I think. And we got negative 90 here, positive 90 here as far as degrees, and 3W here, and basically looks like this. So at 0 degrees, the force is at the maximum. So whatever you get at 0 degrees equals the maximum force. Because basically at 0 degrees, what is this called on a parabola? The vertex. So 0 degrees is at the vertex. Just remember that on this homework problem. All right, next question. Use an ID. Now, we've done one like this one, but I went ahead, since this is a test question, I went ahead and did this one again with a different number. Look in your notes, and I think we did this with tangent equals 5. But use ID, use the identity to find sine of 2 theta and cosine of 2 theta, given the tangent of theta is equal to -2. And I think we did this one with tangent is equal to 5. Somebody confirm that, please. The cosine of theta is above 0. So that means that we're in the what? First quadrant. Well, it could be the first. All students take calculus. The first or the what? Fourth quadrant. But in this case, I think we're going to be in the first quadrant. Did we have one with tangent is equal to 5?
Yes, we did.
Yeah.
Okay, so this is the second one. So you might want to highlight this one because it is a test question. All right, the first thing you're going to do, tangent squared theta plus 1 is equal to secant squared theta because you're given this. So whatever you're given here, you're going to use probably a Pythagorean identity. Why aren't you using Pythagoras? Because you're not using, you've been given enough to use the Pythagorean theorem, but you have been given enough to use the Pythagorean identity. So in this case, plug and chug. I'm sorry, this is tangent. Yeah. So this is tangent. It's going to be -2 quantity squared plus 1 is equal to secant squared. Solve for secant. So 4 plus 1 is what? So 5 is equal to secant squared theta. Therefore, 1 over 5 is equal to what? What's the reciprocal of the secant? Cosine squared. Now use your double angle identity, which is cosine of 2 theta. 2 theta is equal to 2 cosine squared minus 1. 2 cosine squared, did I say minus 1? Cosine of 2 alpha or theta, whatever. 2 cosine squared minus 1. Plug in what? Plug and chug. Because you have cosine squared theta. Now, I wonder if he's on Google. I wonder if you can find him on Google. If you remember his first name. I'll see if I can. So that's going to equal 2 times 1/5 squared minus 1. I don't know, 2 over what? 25? 2 over 25 minus 1? No, 1/5. Sorry, I don't need to square it. I've already got it squared. Sorry, my fault. I caught it before y'all did, so y'all can't say, And that's 2/5 minus 1, and of course y'all can't do this, so you need to type it on your calculator. 2/5 minus 5/5, which is equal to negative what? 3/5? So the cosine of 2 theta is equal to negative 3/5. Now you got that one. Got this one. Now find the sine.
I know I'm like the one that keeps saying stuff, but 2 times 5th squared, isn't that?
No, it's not supposed to be squared. I meant to take that off. See, this is cosine squared, 1/5. So I messed up. I thought I erased it. There. 2 times 1 is what? 2. Okay. 2/5.
Okay, yep, I see it.
All right, now I'm going to go over here and I'm going to write cosine of 2 theta is equal to negative 3/5. Okay, so I'm going to erase everything else. Now remember, what is the tangent? We've got the tangent right here, right? But how can you rewrite the tangent? Tangent of theta is equal to the sine of theta over what?
Cosine.
So you're going to use that. So technically the tangent of 2 theta is equal to the sine of 2 theta over the cosine of 2 theta also. So using that as a, well, we'll use that in just a minute. Let's go ahead and use the double angle with tangent. Tan of 2 theta is equal to 2 tan theta over 1 minus tan squared theta. All right, use that because we have what? We have the tangent. So what would that be? Plug and what? Plug and chug. And you're going to use that with your tangent. You need to find tangent of 2 theta. Or tangent of theta, sorry. Yeah, tangent of 2 theta. Because you've got the cosine of 2 theta, and you want to find the what? The sine. So basically, you're going to use this to get tangent of 2 theta, sine of 2 theta, sine. You're going to plug this in, you're going to plug this in, and you're going to solve for what? Sine. So, tan of 2 theta is equal to 2. So somebody tell me what the tan of 2 theta is. Negative 2 over Let me erase my stray. Did anybody hear from Miss Dawson, or did she just quit? 1 minus -2, quantity what? Squared. And what's 2 times -2? -4. Oh, we might as well forget this. 1 minus 4 is what? -3. And that's equal to 4 what? Thirds. So the tan of 2 theta, let's write that down. Tan of 2 theta is equal to 4 thirds. Y'all check my math. Let me check my notes. See if I did my math right. Yep, 4 thirds. Now, if we've got the tan of 2 theta and the cosine of 2 theta, what can we find? Plug and what? Notice I said plug and chug at least 3 or 4 times. If you have your identities and you go into this thing with, okay, what can I use here? What can I use here? Does it take practice? Yes. You don't sit at a piano and play Beethoven's Fifth the first time you take music lesson. You're going to have to work at this. That's why 10.1, 10.2, 10.3 is so important. That's why I skipped over 9. What is it?
6.
9.6 and 9.7. Because your success in calculus is not dependent upon 9.6 and 9.7. All right, so here we go. 4 thirds is equal to sine of theta over,
The sine of 2 theta.
where is it? -3/5. Okay, now you sit there and stare at it for 15 minutes. Or you multiply both sides by -3/5. Now, believe it or not, you don't have to use a calculator. -4/5 is equal to the sine of what?
2 theta.
2 theta, thank you. And you feel good about yourself. So hopefully some of you that play a musical instrument know what I'm talking about. Hamilton, how many of y'all up there play a musical instrument?
No. I don't think
Nobody at Pendleton plays a musical instrument.
No.
I've never had that happen before. Usually there's one person that plays. Anybody here? Okay. Anybody at Easley or Oconee? Miss Billy, what do you play?
A viola.
Okay. What about on the left side? I can't see who that is. Okay. What do you play?
The guitar and a piano.
Okay. First time you played it, did you play a song the first time, or did you just pick at it?
Pick at it. You have to like learn to feel it, I guess.
Eddie Van Halen, do you think he played the pieces that he plays, you know, the first time he played the guitar? No. And do you remember back when I told you, or in algebra, when you were told to use the reverse FOIL method, the shortcuts, and you were told to learn those? That was your first musical instrument in algebra. Identities is complete the square is your second. Third is the identities. So if you want to continue to be good at calculus, at solving equations in calculus, you're going to have to learn these identities. And the only way not to suck at them is to what? Practice. And again, we're going to use that 3-word term, raising the bar. That's why people hate Chick-fil-A. They raise the bar. Chick-fil-A is evil. because they raise the bar. They expect things out of their employees. They're kind and polite to their employees. And these other people just can't understand why Chick-fil-A is so successful. Here we go. Cosine squared of 112.5 minus, hint, hint, sine squared of 112.5. The angle is the same, and there's a minus in This might be a double angle identity. Or double number identity. Sine of 2 theta is equal to 2 sine cosine. And cosine of 2 theta, I'm just writing them down, equals cosine squared minus sine squared. So you might be able, and I'm going to write down the tangent also. Tangent 2 theta is equal to 2 tan over 1 minus tan squared. So there's the double angle identities. And actually this one does not take very much as far as, because it looks like, which one? This is a, let's see, sine of 2 theta. So, yeah. So this is the cosine, which is a minus symbol right there. So cosine of 2 times what?
12.5.
So I went from this side to what? That side. Again, is this a difficult problem? No. But what happens is you look at it and you just stare at it. You've got to have your identities either learned or you've got to have them in front of you. And that's going to be, what's 112.5? What do you get? 225? Cosine of 225, and oh my gosh, that's a special angle. Square root of 2 over 2. And that's your answer. All students take calculus, so the cosine is going to be what? Negative.
That is test question.
I'm sorry, what?
Is that a test question?
Oh, yeah. The reason I give it, does anybody know why I give that test question?
See if you know.
Because it's very what? It's very simple, but if you don't know your identities, you just sit there and what? Stare at it. All right, here's another one. Now what I did is I go through the homework questions, and if I see 3 number 3s, I just pick one and I do that one. So I've gone through and I've picked out, some of these cover about 3 or 4 of y'all's questions. So you need to look at your questions and see if these look like your questions. Because there's no way I can do every one of your questions, because I had about 28, 30 questions sent to me. Which I'm glad. Use ID to write as a single trig function. Use IDs to rewrite a single trig function. Or whatever. 1/10 minus 1/5 sine squared of 51.3 degrees. Now I want you, first of all, I want to get rid of the 1/10. So I'm going to factor out a 1/10. Now y'all should be able to do this because we did it with completing a square, when you divide by 1/10, you multiply by what? 10. So you should be able to do that with the 1/5 and not have to use a calculator. Please tell me you don't use a calculator to do that. So what's 10 divided by 5?
2.
Thank you. Okay, now I want you to focus. The 1/10 is outside. Don't focus on the 1/10. Now you focus on 1 minus sine squared because that's the most complicated. And it sure does look like a double angle to me. Which one? Look for 1 minus sine squared. Look at the double angle identities and look for 1 minus the sine squared.
Cosine 2a.
What do you say?
Cosine 2a.
Thank you. Who said that? Raise your hand. I know it's not Pendleton. So come. Good. We get a reaction out of Pendleton when we know that they don't say an answer. Way to go, Pendleton. So 1 minus the sine squared is equal to cosine of 2 theta. So I want you to somehow work that into that problem right there. So you could rewrite this. How could you rewrite this using this? Cosine of 2 times what? 51.3. So 1/10 times cosine of 2 times 51.3 degrees. And I don't know what 51.3 because that's 102.6. So your final answer is 1/10 times cosine. I don't forgot. 102.6. Help me out.
Yeah, 102.6.
And that's your answer. Now, why didn't I simplify it? The directions just said what? One trigonometric function. So if you took that down, you probably would get the answer wrong on the test because you took it down too far. Next question. Andy, how are we on time? I trust you, Mandy. I don't trust anybody else.
About 20 minutes.
Got 20 minutes? Because I got questions for days. Oh, I do have a question. I just wanted to ask. Did any of you use the supplemental instruction? Because he sends out 15,000 emails.
Yeah, he does.
Okay, have y'all used them?
He does.
Yes.
Well, you have to check your emails.
I do.
Well,
I've been
Well,
reading.
We're not on the mail list.
Well, I've got like 5 emails from him. I don't know if it's a him or her. I don't know. I don't read it. So I just know it says SI instructor or S. I did supplemental instruction when I first started here. That was back in 1996, and they think it's something new.
Maybe they only like Pendleton.
Yeah, of course. That's where the sun revolves. Okay. Use half number or angle, whatever you want to call it, half angle, half number, identity to rewrite the sine of 5 pi over 12. Now you don't have to per se find out where you are on this one because they're telling you what to use. They're telling you to use the half angle identity. So that's going to be the sine, since it has sine, of alpha over 12, or theta over 2 is equal to positive or negative square root 1 minus cosine of 2 theta over 2.
Have we seen these in this?
You see them now. They're on the identity sheet. I mean, this is 10.3. So if you look in 10.3, you're going to see these. And I haven't per se went over them in class, but I guess you could say that's what we're doing right now. Unless you want me to derive them, I can derive them if you want me to and show you how they come about. No, I don't think that'd be fun.
So just look up half.
Well, it's on the sheet when you do. When you go to Google. Now this is a lot of work. Remember, this is a lot of work. So I don't know if some of y'all can do this. I think I already pulled it up. Yeah, here's a good cheat sheet right here. I pulled up Trig cheat sheet. And there they are. There's the double angles right there. Or they call it half angles. I'm sorry. Half angles. Yeah, but yeah, it's a good. I know, Pendleton, you might have to hit the button like 3 times. Or you might have to print 3 sheets. So a lot of work.
Let's do it, Hubert.
Yeah.
I've used that.
Can you send us a link? Email it?
I made my own.
Really?
It's better.
Just look up Trig cheat sheet. And you should be able to find 5,000 or 6,000 to pick from. All right, so here's the I just told you, if you look, well, where is my, okay, hold on. There is my directions. Use half angle identity. So going back, there's the half angle formulas. So, of course, I picked the sign. Why did I pick the sign? Say it one more time. Because it says sign. That's why I picked the sign. So I'm just trying to show you that this problem is not difficult. You shouldn't have to sit there and stare at it. But you have to do one thing. You have to find what's 1/2 of pi. What makes this angle? All right. And the way you do that is you say 5 pi over 12 is equal to 2x. And then you do the formula and you get that 5 pi over 12 is equal to 5 pi over 6 multiplied by what? 1/2. This angle right here is important. This is the angle that you multiply by 2 to get what? 5 pi over what? 12. Now that's important. So this, when you do that, this right here is A, or theta. Okay? So now you're going to take that and plug in what? Plug and chug. So plug and chug. Now, first of all, you need to find out where this is. Now, what is 5 pi over 12? What is 5 pi over 12? 5 pi over 12 multiplied by 180 over pi. And 12, let's say 6 will go into 12 2 times. 30, 15. 5 times 15 is what? 75? Help me out. 75 degrees? Somebody check my math. That means I want somebody to check me.
That's right.
Okay. So where is 75 degrees? In the first quadrant. All students take what?
Calc.
So that means that this is going to be what? Positive. So I go over here to my positive and negative, and I subtract the negative. Why did I subtract the negative? Because we're in the what quadrant? Okay, that's important that you do that. So sine of 5 pi over 6 Make sure I'm doing it right. Okay, you don't have to come in and doing the right side. Equals the square root of 1 minus cosine of 5 pi over 6 over 2. Now you've got to find the 5 pi over 6. Well, what is 5 pi over 6? Let's go over here. 5 pi over 6 multiplied by 180 over pi, 6, 30, 150. Y'all check me.
Yep.
So 150 is going to be what? 30 degrees. And I'm just doing it if you don't want to memorize it. So 30 degrees is square root of 3, 1, and 2, right? And that's going to be a negative and a positive. And so what is, we want the cosine. Oscar had a hump, so it'll be negative square root of 3 over 2. So equals 1 minus negative square root of 3 over 2 over 2. And now finish it out. Now they do not want you to get a decimal. They just want you to finish it out with a radical. Somebody got questions?
Yeah, I got one.
What is it?
What happened with your 2 from your formula? Like
I
on the
didn't hear
left-hand
what?
side. What happened with your formula? It should be cosine 2 theta, right?
I think you were right. Hold on. No, cosine. I messed up there. You have to read it off. I just stuck a 2 in there for some reason.
Okay.
There you go. Okay, everybody gonna say it?
I was confused. Right?
I was confused. Okay, everybody say I was confused, but I thought it was. Okay, finish it out. So that means
I have one more question though. Really.
what?
Where did the 1/2 over there go? You did 5 pi. Oh.
Over here?
I'm confused what you did over there and where it went.
Okay, where are you talking? Hold on.
So 5 pi over 12 equals 5 pi over 6 times 1/2. I don't know.
Okay, you've got to find what angle. Okay, this is the angle you're given. All right?
Yeah.
So basically, multiply that. Okay, you can do it by dividing by 2, or however, what makes that angle?
Oh.
And you got to use this 1/2 because this 1/2 is right here. So you've got to find out what angle do you multiply by 1/2 to get that angle. Now, if you want to divide by 1/2, you can do that.
Gotcha.
So think about that. Just divide whatever angle you're given. Sorry, I can't spell. What angle you're given, divide it by 1/2, which means that you're going to multiply by what? 2 over 1, which means 5, 6. So that may be what you want to do.
Okay.
All right? So this is going to be, and that's going to be the square root. What is 2? That'd be plus. So I've got 2 plus the square root of 3 over 2. Or I'm sorry, 1. Yeah, 2 plus the square root of 3, and all of that is over 2, divided by 2 over 1, which means I'm going to multiply by 1 over 2, which means I'm going to get the square root of 2 plus the square root of 3 over 4, which means that I'm going to get the square root of 2 plus the square root of 3 over 2. That's your answer.
I wasn't sure about this one.
I said I got 2 plus the square root of 3 over 2. Yeah. Square root of 2 plus square root of 3 over 2.
Yeah.
How many minutes? Like 5, 6 minutes?
10.
10. All right. Let's go ahead and do this last one. And all of these are good test questions, so you might want to write all these down, you know. The only one that I suggest is not a good test question was the formula one, because that's kind of just like plug and chug. So this says the tangent of beta over 2. My betas do not look like betas. So you can go jump in the lake if you make fun of my betas, all right? Comma, given tangent of beta is equal to the square root, negative square root of 11 over 5. With pi over 2 less than beta, this is all given, less than pi. So that means that the given information is in quadrant 2. Right? Yeah. Because pi over 2 is 90 degrees and pi is 180. So it's in quadrant 2. This information, you're in quadrant 2. Now you know you're probably going to go ahead and use the Pythagorean theorem because they give you, what is tangent? Oscar had a hunk of what? Of apple. So you're given 2 things, so you might as well use them. And you know that it is in the first quadrant, so both of them is positive. But the second quadrant, all students, that means that you have a negative, so which one's negative, the adjacent or the opposite? The adjacent, Hubert. That's right, class. So, the adjacent, I'm going to use another color here. The adjacent is right there, and the opposite is right there. So which one is this one? The opposite is this is negative 5, so that's going to be negative 5. And this is the square root of what? So now you can find your what? Hypotenuse. So find the hypotenuse. And the reason you need to find the hypotenuse is you're going to need it later. So we'll go ahead and do that. Negative 5 squared plus 11, square root of 11 squared, square root, the square root of 25 plus 11, square root of 36. Look at there. Okay, so now you've got, and you need to write that down somewhere. You need to write that triangle down because you've got everything you need. So, we got a tangent, so we're going to be using tangent of beta over 2 is equal to positive or negative square root of 1 minus cosine of beta over 1 plus cosine of beta. And that is your half angle with the tangent. Now, since I've got beta over 2, now this is a trick you can use. I'm going to take another color, and I'm going to take this tangent of beta over 2. Since I'm dividing by 2 here, I'm going to divide these by 2 and watch what happens. Everybody with me? So what's pi over 2 divided by 2? Pi over what?
4.
And then, look here, beta over 2, which is what we are using, less than pi over what? 2. So now it's going to be, tangent will be positive because, yeah, tangent will be positive. So therefore, we're going to erase the negative. So what is the cosine? Cosine is what? Oscar had a hunk, negative 5/6, correct? But it's in quadrant 2, so it's going to be negative 5/6. So equals, let me go back to black, dang old ACDC. So that's going to be square root of 1 minus over 1 plus, and that's going to be negative 5/6. And that's going to be negative 5/6. And crank it out. So that's going to be, well, we're going to turn this into a positive. This is going to turn into a positive, and this is going to turn into a negative. So that's going to be the square root of 6/6 plus 5/6 over 6/6 minus 5/6. Everybody with me? Which is going to be equal to the square root of 11/6 divided by 1/6 multiplied by 6 over 1, which is equal to the square root of what? 11. So the tangent of beta over 2 is equal to the square root of 11. Well, I timed that just right. That's the second set of homework questions. Now I got to work on the third set and get y'all ready for the third set. By then, y'all should have 10.1 through 10.3 done. If not, we all know what that means. All right, y'all get out of here. I'm giving everybody attendance. So y'all get out of here and work on 10.1 through 10.3.